Okay, so now we are going to question 13 on the short answer question. So we are going to find for errors. Now, this is not a simple one, which is fine because what we need to do is we need to be able to follow the thinking of the person who makes the question. All right. So what we're gonna do here is that we're gonna say that in here we it's basically generating. So if you have a character of, let's just say, A, B, C, D, E, F. So if we get like 8, 1, 2, 3, 4, 5, 6, 7, 8. So let's just do digit solutions. 1, 1, 2, 3, 4, 5, 6, 7, 8. Hey, that sounds good. So if you enter solution in here, it will come up with the gibberish character like this one. 1, 2, 3, 4, 5, 6, 7, 8. So that is what this encryption thing is doing, algorithm. Right? So the first begin, then we start, and then we have a variable called word, which is basically we getting it from the user, and then row number 3 here, word converted to lowercase. So let's just assume we have solution. That one will become solution converted to lowercase. Then we have plain text, word converted to array. So array, basically what we're doing here is that we just separating it. So let's just do this. So O L U T I O N. So we're separating the word into an array, or just like if you think about like an array as a train. So every carriage has one character. So you have a long character, and with array, it always have an index. So this algorithm starts from index 0. So basically what happened here, this is index 0, 1, 2, 3, 4, 5, 6, 7, right? So that's row number 4. And generate OTP key will return an array of 8 random numbers. So we have another variable called key, and then that will also give us 8 random numbers. So let's just pick a random number. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. Let me just bring it closer so you guys can actually see what the variable looks like. So that's what it looks like. So we have two variables with arrays, and all of them has the data in there. Right. So now we're gonna have a ciphertext. So we have row number 7, ciphertext, and then what this one here is that currently we're gonna have an array of blank characters. So as we go through the working, we will populate this. So let me check. 1, 2, 3, 4, 5, 6, 7, 8. All right. So we have 8 characters here. So let me just put a number here so that we can replace it later on. Right. So what we're going to do is we're going to translate that into the ciphertext. Okay. And then alphabet is lowercase alphabet converted to an array. So we have alphabet equals, it's basically A, B, C, D, E, F. So H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So you need to become the computer in processing this. So don't think ahead of yourself. You only work with what you have. So row number 9. Now this is the one that you have in here. Okay. So for I from 0 to 9, well, technically I 0 to 9 is fine. But generally, when you use a loop here, you want to access an array. So when you are accessing an array, we have a question here, okay? So we are accessing this array. Where the hell do we accessing it from? Or how many arrays do we have in the system? Well, we have plain text, we have key, we have ciphertext, and we have alphabet. So I, if you look into it, I is currently being used in the alphabet. So if you go in there, so now we have a problem because alphabet is 7. The length is 7, but this one 0 to 9, which means that it will generate an error. So that's the reason why in here we need to adjust the I from 9 to 7 because we want to go through all the plain text array, all the alphabet. Oh, no, no. So it's 7 or 26. So it's either one or the other because the alphabet is 0 to 26. So the answer here is going to 7. The reason why it is going to 7 because the I is going to be used to traverse through the plain text array. How do I know it? Well, you only have two options. You either have 7 or 26. So as you go through them, are you gonna are you going to iterate through the alphabet array, or are you going to iterate through the plain text array to convert it into the ciphertext? The answer is you're going to iterate through this. So that's why it's 7. Right, so question number 10, alphabet location. So we have alphabet location, which is alphabet location equals -1, which means that it sits all the way to the left. So it sits all the way outside the alphabet array. So this one here is 0, 1, 2, 3, 4, 5. I'm just gonna do a little bit here, up to 10, and you can understand what I mean. So alphabet location, it starts from the -1. Yeah, we don't have any problem with that. Okay, cool. So now for J 1 to 0 to 25, now that makes more sense. So as a wrong color, sorry, let me change my color. So J 0 to 25, so that means the J, it's going for the alphabet. So that makes sense. And then we only need 0 to 25 because there is only 26 elements. So the next problem that we're going to find is that once we go in here, it's trying to compare the two array. So it's trying to compare, it's looking for the plain text for S here. Then it go and check whether it will try to check where the position of the S in the alphabet. But the problem in here is that the plain text is using the J index and the alphabet is using the I index, which is a reverse because that one should be a J index because we need to go through 25 of them. This one here should be an I index because we're only going to 1, 2, 3, 4, 5, 6. So what it's doing here is that it goes through here and then it's fine. Okay, I have S here. Let's find the S index in here. And then we set it in the alphabet location. So that one is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it will save alphabet location is now it's going to save it to 19. Okay, so we have 19. All right, cool. So we have 19, so that's good. So and if and for, so that is go and search for. So it starts from the first character. It searches the index where it's located, and then check if not found. So if alphabet location is bigger than equals to 0, which means that we found the letter. So we found S here. And then what we're going to do is that we go ciphertext. So we're going to convert this index back to here. Ciphertext is that alphabet location plus key of the I, which is that one there, and then mod 26. That doesn't make sense. The first problem is that the alphabet here, this is an array. So for an array, you don't use a bracket command. So that's why I say it's a bit tricky because in here you need to know your variables. So for an array, you actually need to have My square bracket sucks. You need to have an array bracket, so that's why you need a square bracket. Okay, and then what it's doing there is that the key, so alphabet location 19 plus key at position I, so key is J, so 19 plus J, and then we have mod 26. So the answer for the thingy here is that they're saying you need to have the square brackets, which is the array. So what it's doing here is that J is actually a character as well, probably. So alphabet location, which is 19, and then J will be a character index, or, oh, sorry. No, my bad. The key is not a letter, so that's probably why I'm confused. It's generating 8 random numbers. So we got 8 random numbers. So that's probably why. So that now makes sense. So now we got 19, the position of S, and then we add it back with the key of 8. So we have 19 plus 8, which is then equals to 27. Now, you do have this command here, modulus. So what that one will do is that they will try to divide 27 divided by 26, and then the modulus will get the remainder. So it will have 1. So 1 times 26 equals 26, and then we have a remainder of 1. So we are focusing on the remainder of 1, and then the remainder of 1 here, that goes to B here, right? So once that goes to B here, then it will ciphertext I. So it basically say at the ciphertext, it puts this one here, it puts an I. So ciphertext. So eventually this will become like this. Uh, there's not supposed to be an I because there's a, yeah. So it will end up like that. So you are modifying the ciphertext based on the array, right? And then what you need to say is that, okay, so that is good. So we got 1 error, 2 error, 3 error. So the last error is the output, because if you do a ciphertext at the index I, well, first of all, your index I will be on 7, so it will just get the last one. So we don't want that. We want the whole thing. So that's why your last error is that you do a ciphertext. Well, that's very long, and I know it's very confusing. Happy to walk it through it again. But what I will do is you need to put your brain as the computer. You are the computer, so you need to be able to translate this command into a computer recognizable command, and then you will be able to understand and identify the error. Hope it helps.